This is one more salt problem. What is pH of 0.3 molar potassium fluoride? Now you should realize this comes from hydrofluoric acid, which is a weak acid, plus potassium hydroxide, which is a strong base. Then when neutralization took place, it was 100%. It's not equilibrium and gives you a salt. At this stage, you should say, since it's weak acid, strong base, this is a basic salt. And then we like to bring its pH to life and see if it's really bigger than 7 plus H2O liquid. Now from potassium fluoride, only fluoride reacts with water because it is the conjugate base of a weak acid. It reacts with water. Since we said it's basic, it will produce hydroxide ion plus hydrofluoric acid again. And if we know amount of hydroxide, we can find POH and then pH. So let's go after ice. Initial we have 0.30 molar minus X amount, and then the same due to 1-to-1 ratio, X moles of products come to life. Since it's basic, it's Kb equals X squared over 0.3 minus X. Now if you note, we don't have Kb, rather Ka of the acid is given. So what we should recall is Ka times Kb was Kw, and also pKa plus pKb is equal to 14. So I'm going to use the first equality, bring it down here and say Kb is nothing but Kw, which is 1 times 10 to minus 14 at room temperature, divided by Ka, which is 7.2 times 10 to minus 4, and this becomes 1.39 times 10 to minus 11. So this is equal to 1.39 times 10 to minus 11. We make our assumption that Kb is extremely small, much smaller than 1, that you can say the denominator is just 0.3. So X, which is our hydroxide concentration, is square root of 0.3 times Kb and that becomes 2.0 times 10 to minus 6. So POH is negative log of that. And it's 5.69. And finally pH is 14, take away 5.69, which is equal to 8.31. So we proved it is a basic salt. We also calculated its pH, which is above 7, so it's basic.